Hello, welcome to my YouTube. Today we are going to answer a question on linear inequalities. So linear inequalities, you have it in paper 1, and of course you have 5 marks mostly. So this question goes like this. Write 4 inequalities that define the unshaded region R on the diagram below. So we have R, and R, it is surrounded by these inequalities. Of course, R here is a place where it's not shaded. And now the question is saying write 4. So where you get the 4 inequalities, you get it from this 1, 2, 3, 4. Now you can start with any here, it doesn't matter. So here, I'll start with this one here. So since I want to start with this inequality, the first thing to do, you have to check first if at all the line is solid or dotted. So when I say solid, we are talking about a line which has no dots. It can be vertical or horizontal or a slope. It doesn't matter. So long as it's so long as it doesn't have dots, then you say it's solid. Okay, so again, we also have another type of line which is dotted. Dotted, it can be vertical or horizontal or a slope. It's still dotted. So in this case, since we are saying we'll start with a line here which is vertical. So for all the vertical lines are for X. So meaning this line here is cutting x-axis. So I'll write x. After writing x, I'll check now. This line is passing through which number on x? 6. 6. Then here now I'll put the inequality. So for the inequality, we have 4 types of inequalities. 4 types. We have less than or equal to, greater than or equal to, less than or greater than. These are the 4 inequalities. Now, from the same 4 inequalities, you group them into 2. So these here, which have equal to, they are group 1. Then these now, which has no equal to, group 2. So now you check if a line is dotted. If a line is dotted, then you use any of the 2 inequalities. If the line is dotted. If a line is solid, then you can use one from the 2 inequalities here. So now, since our line there is dotted, so you check which inequality should I use. So it's here where you can't guess. So I'll use a shortcut for you to know that which inequality should I use here. So for you to use this or for you to use this, come here and check where it is shaded. So where it is shaded is on right side. So if the shaded side is on the right, then you use less. So when you hear right side, of course, have that in you that it has to be big. So if the shaded side is big, then now here you use the opposite one, which is less. That's the meaning of unshaded. So meaning here now you go for which one? Less than, because the right side it was shaded. So this is inequality 1. The second inequality, I will go for this one here. Now we are talking about horizontal. So for horizontal, all the lines for horizontal, you use for y. So this line here is horizontal, so you use y. Next, now you check this horizontal line is passing through which number? 1. So meaning you have 1 here. Again, check the type of a line now. So the type of a line here is solid. We said if it's solid, it's either you go for less than or equal to or greater than or equal to. Any from the 2 here. So this is what you do. Check now the side where it is shaded. In this case, the side where it is shaded, it's down. If the down part is the one which is shaded, you get the opposite for down. So down, you can see it as less. So here, the shaded part is less. So now you pick the opposite. So opposite of less is what? Greater than. So meaning here you have greater than or equal to. So this is inequality 2. we have remained with the 2 more. So 2 more, again, you can either pick this one here or this one, it doesn't matter. Now, if a line now is a slant or a slope, meaning you need to have 2 letters, x and y, on it. So this is what you do. Since we are saying a line now, here it's a what? It's a slope. So if it's a slope, that's the part where you use the equation for a straight line. So equation for a straight line, you say y minus y1 equals m, open bracket, x minus x1. Don't panic, it's still the same formula for y equals mx plus what? C. It's still the same. The only advantage for you using this formula here is because you won't have that part of finding C. You just go direct here, you just find M. If you use this, then you have to find M, gradient, then from there again you find C, then you go back again. But for this one, you just find M, then you substitute, then done. So that's how simple it is using this formula. So this is the formula you use. It's still the same formula you use also on calculus on when you are writing the equation of a what? Tangent. So tangent and the straight line is the same. So now check, you need M here, you need M. Where you get M, here you need 2 points. You find gradient using the formula for 2 points. Where you say y2 minus y1 over x2 minus x1. So you need 2 points. Where you get the 2 points? From the same line. So here, where this line is cutting y, you have a point here. So whenever you are on y, x is what? 0. So meaning here we have x is 0. Y, the same number here, 3. 1 point. Another point, you can't guess here, unless if this question comes on a graph, then you can get any point here. You just get x, y. Even here, x, y. But a question like this, where it's not on a graph, just come where it is cutting the x-axis. So it's cutting the x-axis here. So when the line is on the x, understand that y is 0 and x is the same number which is here. So in this case, x is what? 6. Then y, whenever you are on x, y is what? 0. Here, whenever you are on y, x is 0. Then y, you get the same number. So now we have 2 points. From the same 2 points, it's up to you to say this should be my first point and this to be my second point. Or you can swap, it's still okay. So I'll go for this one. I'll say x1, y1, x2, y2. From there, I'll substitute here. Where there is y2, I'll get my y2, 0, minus y1, 3, over x2, 6, minus x1, 0. So 0 minus 3, negative 3, over 6 minus 0, 6. A number to go in both 3. 3 here, 1. 3 here, 2. So that's my gradient. That's my gradient. It's okay again for the formula for gradient. You can start with y1 minus y2. x1 minus x2. It's still the same. Okay, from there now you substitute here where is m. Now you say y minus y1. y1 maintain the same points. y1 now is what? 3. Equals, where there is m, you have negative 1 over 2. We have x here. Minus x1, you have what? 0. You have 0. So here you say y minus 3 equals negative 1 over 2. X minus 0 is what? X. But if you add a number here, don't solve them. So in this case it's 0, so we'll take advantage. X minus 0 is what? X. So meaning you have x here. We need y to stand alone. So meaning negative 3 will move to the other side. Then you say y equals negative 1 over 2 x. Negative 3 when it crosses becomes positive what? 3. This is the equation. What we need is what? Inequality. So for the inequality, you remove equals and put the inequality. Now from the 4 inequalities, check the type of a line you are using. A type of a line you are using here is what? A type of a line you are using here is what? Solid. So if it's solid, then it's either you pick this or this. Now check the side where it is shaded. Down part is shaded, lower part is shaded. If it's lower, it's the same as less. Now for the inequality, you get the opposite for less. So the opposite for less here is what? Greater than or equal to. So meaning you say y greater than or equal to negative 1 over 2 x plus 3. So this is your third what? Inequality. Okay, we do the last one. So our third inequality, you write there where you have space. So this is our third inequality. The last inequality now. So make sure that you understand here. If you want, you can be testing, you say which one is greater, but now paper 1 you won't have enough time. So this method I recommend. Here now we have the last inequality or the last line. Again, it's a slope. If it's a slope, get used with this formula. So this is the formula here. So this is what you do. You have m here. M here is what? Gradient. So you say m equals y2 minus y1 over x2 minus x1. You need 2 points. 2 points, you get them from the line here. It's here where I said any point. If you are on the graph, you can just get any point here and here, anywhere. But in this case, check where it is cutting y. It's passing here. If it's passing here, then x here is 0 and y is what? 0, where the two intersect. So here you have 0, 0. The same line is also where passing through here. So meaning you have a point here, which is 6, 6. So those are the 2 points. So this is what you do. You say x1, y1. And again here you have x2, y2. y2 will be what? 6. Minus y1 will be what? 0. Over x2 will be what? x2, 6. Minus x1, 0. 6 minus 0, 6. Over 6. 6 into 6, 1. So that's your gradient. Next now. We have y minus y1 will be what? y1, 0. Where there is m here, you put what? Gradient 1. Open x minus x1 is what? 0. So here y minus 0, y. Then we have 1 here. X minus 0, x. So 1, if you want, you can say, you can just remove it if you want. If you want, you can write, it's still okay. So this is your equation, but what we need is inequality. So check the side where it is shaded. The side where it is shaded is what? Up. But before that, understand that the line here is what? Dotted. If it's dotted, 2 options. 2 options only. Now you can't guess here. So this is what you do. Check the side where it is shaded. So the side where it is shaded is up. Up is the same as what? Big. So the opposite of big here is what? Less, which is this. So you say y less than what? X. So this is your fourth inequality. Then you have 4 marks here, 5 marks.